Hi dear students, this video is useful for 8th standard onwards. Okay, today I am going to teach a new topic, that is resistive force. When object is moving in a fluid, the fluid exerts one resistive force opposite to the velocity of the object. Okay, in frictional forces we discussed when one object is moving on another object, there will be one force that will oppose the relative motion. Okay, so for frictional force means one solid on another solid, one object or another object. But here when object is moving in a fluid medium, fluid means air and liquid. Air we can call as fluid, and liquid also fluid. Okay, suppose this is simple marble. Okay, I am dropping here. What happens? It is moving in the air downward. Air also has some resistive force. When it is moving down, air will oppose the motion of this marble. One resistive force will be there opposite to the speed of this marble. Okay, similarly, if you drop this marble in the liquid, I am taking water. Okay, then what happens? This liquid definitely will oppose more resistive force compared to the air. Okay, when I drop like this now, of course it is moving very fast, but compared to air, this liquid will oppose the more resistive force. Okay, this resistive force is proportional to speed of the object that is going down. Okay, it is some kind of material, and same resistive force is proportional to square of the speed. Okay, these two will discuss in this class. Watch forward, you will understand very clearly.
This is class number 70. Motion in the presence of resistive forces. Some important points I will explain here. The first one is like this. Interaction between the object and the medium through which it moves. Okay. Second one. Medium can be either a liquid or gas. Third one. The medium exerts a resistive force R on the objects moving through it. Okay. The fourth one is resistance force due to air is air drag. Fifth one. Resistance force due to liquid medium is viscous force. The sixth point. The direction of resistive force R is always opposite the direction of the object's motion relative to the medium. Suppose the object is moving downward inside the medium, this resistive force is upward. Okay, the seventh important point, this resistive force R is proportional to the speed of the object inside the fluid. So V is the speed. Means as speed increasing, this resistive force increases. It is valid for objects falling slowly through a liquid and for the dust particles moving through air. This formula is valid for this condition only. Okay. Another important point. This resistive force is proportional to V square. It is proportional to square of the speed. It is valid for large objects. Example, skydiver moving through air in free fall. In that case, this resistive force is proportional to the V square. See here, I am plotting the graph of speed of the particle versus time. This is a beaker contain water. Okay, one liquid. I dropped one stone inside. the mass of the stone is m. So downward force is mg due to gravity. Because of that, the stone is moving downward. The velocity keep on increasing. As velocity keep on increasing, opposite direction to this velocity, one resistive force is there, upside. Because of this resistive force, as velocity increasing, this resistive force also increases. This resistive force is proportional to velocity of the object, that is going inside the liquid. So resistive force R equal to minus BV. V is the velocity of the particle inside the liquid that is moving. The direction of resistive force R is always opposite to the direction of velocity of the particle that is moving inside the liquid. Okay, so what happens? This Vt is terminal speed. You see this graph, x-axis is time, y-axis is speed of the particle inside the fluid or liquid. Initially, the speed is keep on increasing. After some time, the speed remains constant. So, this speed I am calling as terminal speed. After this time, this particle will move with constant speed. When it is moving with constant speed, the net force will be zero. Downward force is mg, upward force is bv. So for terminal speed Vt, the downward force mg equal to upward force bv. B is one constant. Okay? You understand now? So the graph for speed and time is, it looks like this. It will saturate. The speed will be finally, it will be constant. See here we'll solve one problem. A small marble of mass 3.0 grams is released from rest in a large vessel filled with oil, where it experiences a resistive force proportional to its speed. The sphere, that is marble, reaches a terminal speed of 6.0 centimeter per second. Determine the time constant. In the previous graph, I have given the relation, that is V equal to Vt into 1 minus e power minus t by tau. This tau is time constant. This Vt is terminal speed. This V speed is changing with time. Okay. So before doing that, first you see this free body diagram. When it reaches the terminal speed, downward force is mg, upward force is r. Both are equal. The speed is fixed. Net force is 0. Means it is not accelerating. So r equal to mg. R is nothing but b into vt. Vt is terminal speed. So b is equal to mg by vt. You substitute, you will get, this is a coefficient. B equal to 490 grams per second. This is a coefficient. So we have to use this coefficient to find out the time constant. The time constant is equal to, formula is like this. Tau is equal to m by b. M is the mass, that is 3.0 grams divided by b we have calculated, that is 480 grams per second. So we got time constant equal to 6.25 millisecond. Okay.
Please like this video, share this video and subscribe my channel and tap the bell icon to get the notification for further uploads of my videos.